Today we are going to solve the examples based on the Bayes' theorem. First of all, we'll see the statement, the formula that is used, and then we'll see the examples. Let's take events A1, A2, A3 up to AN, which are mutually exclusive and exhaustive events, where the probability of the event A is not equal to 0, I is from 1 to n, and the sample space is S. Before we see the further statement, let's discuss what do we mean by mutually exclusive and exhaustive events. The events are said to be mutually exclusive when both of the events can't occur simultaneously. Like suppose if we are tossing a coin, then both head or tail can't occur simultaneously. So these type of events are mutually exclusive. Now exhaustive events means the total number of possible outcomes of a random experiment. That is, if we are tossing a coin, then we have two outcomes which can be either head or tail. So it's the total number of the possible outcomes of a random experiment. Let's continue the statement. We have the other event B that can occur in combination with any one of these events A1, A2 up to AN, and the probability of B is not equal to 0. As per the Bayes' theorem, the probability of the event AI when the event B has actually occurred is given by P of AI. This line between A and B is known as given that is equal to P of AI into P of B given that AI divided by summation of P of AI into P of B given that AI, and I is equal to 1 to n. In order to solve the examples, you will have to remember this formula. P of AI given that B is equal to P of AI into P of B given that AI divided by summation of P of AI into P of B given that AI. Let's solve this example. A company has two plants to manufacture machines. Plant 1 manufactures 70% of the machines and plant 2 manufactures 30%. 80% of the machines are rated standard quality at plant 1 and 90% of the machines are rated as standard quality at the plant 2. A machine is picked up at random and is found to be of standard quality. What is the chance that it has come from the plant 1? Here we are having two plants, plant 1 and plant 2. And the other thing that we are given is that it should be of standard quality. So from this plant 1 and plant 2, we'll create our events A1 and A2. We have to write it like this. Let A1 and A2 be the events that the machines are manufactured in the plant 1 and plant 2 respectively. And then the machine should be of standard quality. So for that, we'll create another event which we'll call it as B. From the question only we'll come to know what events we need to create. So firstly, for the plants 1 and plant 2, we created the events A1 and A2. And then we'll create the event B, which will be the machine that is picked up and it is found to be of standard quality. Next thing we'll do is we'll find the probability. 70% of the machines are manufactured in plant 1. So the probability will be 70 upon 100. P of A1 will be equal to 70 upon 100, which is 0.7. Then 30% of the machines are manufactured in plant 2. Therefore, P of A2 will be equal to 30 upon 100, which is equal to 0.3. Then we'll find the probability that the machine is of standard quality, and it is given that it is manufactured in the plant 1, which we'll write it as P of B given that A1. Because the event A1 represents the machines that are manufactured in the plant 1 and B represents the event that the machine is of standard quality. So we wrote it like this: P of B given that A1. Now 80% of the machines are rated as standard quality at plant 1. So it will be equal to 80 upon 100, which is equal to 0.8. Then same way, we'll find the probability that the machine is of standard quality given that it is manufactured in the plant 2, which we'll write it as P of B given that A2. So it will be 90 upon 100, as we have 90% of the machines are rated as standard quality at plant 2, which will be equal to 0.9. Now we have to find what is the chance that it has come from plant 1. Machine is of standard quality and it has come from plant 1, which means that the condition here given to us is the machine should be of standard quality and it should be manufactured in plant 1, which means we'll write probability that a machine is manufactured in plant 1 given that it is of standard quality. The probability that the machine is manufactured in plant 1, that means it will be P of A1, and given that it is of standard quality, that is given that B. So we'll write it as P of A1 given that B. Now we'll just use our formula, which is P of A1 given that B will be equal to P of A1 into P of B given that A1 upon summation will come. So it will be P of A1 into P of B given that A1 plus P of A2 into P of B given that A2, because we are having two events A1 and A2. So we'll have to consider both in the denominator. Now you just need to place the values. P of A1 is equal to 0.7. Then we have P of B given that A1, which is equal to 0.8. So it will be 0.7 into 0.8. Then we have P of A2 0.3 and P of B given that A2 is 0.9. Here the numerator will be 0.7 into 0.8 divided by 0.7 into 0.8 plus 0.9 into 0.3. On solving this, we get P of A1 given that B is equal to 0.6747. Let's see another example. A bag A contains 2 white and 3 red balls, and a bag B contains 4 white and 5 red balls. One ball is drawn at random from one of the bags and it is found to be red. Find the probability that the red ball is drawn from the bag B. Here we are having two bags and the condition is that the ball should be red and it should be drawn from the bag B. From this we'll create our events. We'll call the bag A and B as the events A1 and A2. We can write it like this: let A1 and A2 be the events that the ball is drawn from bag A and B respectively, and we'll create another event which we'll call it as B, which will represent that the ball drawn is red. And that will write it as let B be the event that the ball drawn is red. Firstly, we'll find the probability of the events A1 and A2. Here, as we are having two bags, there's only single chance that we can either draw the ball from bag A or from bag B. So we'll write the probability of A1 and A2, which will be P of A1 is equal to 1 by 2 and P of A2 is also equal to 1 by 2. Then we'll find the probability that the ball drawn is red given that it is drawn from the bag A, which will write it as P of B given that A1. The condition is it is from the bag A and it should be of red color. So for red color we have represented it using event B, and bag A has 5 balls, as there are 2 white balls and 3 red balls. We have to draw red ball, so it will be 3 divided by total number of balls, which is 5. Then the probability that the ball drawn is red given that it is drawn from the bag B. Again we'll write it as P of B given that A2, the bag B contains 4 white balls and 5 red balls, which means total number of balls are 9. We have to draw red balls, so it will be 5 divided by total number of balls, which is 9. Then in the question it is asked to us to find the probability that the red ball is drawn from the bag B. We'll find the probability that the ball is drawn from the bag B. Here the condition is it should be of red color only. Given that it is red, and this will write it as, for bag B we have represented it using the event A2, so it will be P of A2 given that B, because we have represented that the ball is red and the event for that is B. Now we have to just use the formula, which is P of A2 given that B is equal to P of A2 into P of B given that A2 whole divided by, here we'll have to take the summation, which is P of A1 into P of B given that A1 plus P of A2 into P of B given that A2. All of these we have already found. P of A2 is 1 by 2. P of B given that A2 is 5 by 9. P of A1 is 1 by 2. And P of B given that A1 is 3 by 5. It will be equal to 1 by 2 into 5 by 9 upon 1 by 2 into 3 by 5 plus 1 by 2 into 5 by 9. On solving this, we get 25 by 52. This way, from the question, you will have to create the events. You'll have to understand which events will be A1 and A2 and which event to call it as B, and then find the values and input it in the formula. Thank you.